Hallo Freunde, ist 10 Uhr am Redmond und es Zeit für .NET API Review. Ich hoffe, dass alles ist gut für euch. Um, I actually was going to pick a language other than German today, but German was the first, or Germany was mentioned in the chat while I had the placeholder up, so German today, or at least my attempt at Danglish. Cool. Yeah, so we have a whole lot of red, and oh look, we are gaining some more people, but we already picked a red thing to start with, and so let's get started. So, issue 68868, char helpers for common ASCII categories, Mr. Tobe.
Can you hear me?
Yep.
All right. So Char already has a whole bunch of is methods for lots of different categories to determine whether a character is in one of those. Char.isLetter, char.isDigit, char.isControl, char.isASCII, char.is whatever. But there's a set of categories that we frequently find ourselves manually coding a check for that we don't have is methods for. And we have lots of different, in some cases, we have many different implementations floating around of varying levels of efficiency. And we can kind of do the one right, the one true implementation in one place rather than having this in a bunch of places. Um, and so this is my proposal for an initial additional set to add, basically focusing on these ASCII categories that frequently come up. Is it not just is digit, which is about 370 characters, but is ASCII digit, which is the 10 that most people think about. Similarly, is ASCII letter, which is just A through Z, uppercase, lowercase, and then just the lower or uppercase versions of those. And then also, is it a letter or a digit? And I picked these primarily because in looking around multiple repos, including .NET Runtime, these are the categories that very, very, very frequently come up. They also show up frequently in regex patterns. And so regex will end up just calling these helpers when it sees one of those character sets. But if you want, I went through the repo quickly and used these. And you can see if you scroll down to the bottom, I have a comment with a link to a commit. Yeah, right there, which shows just how prevalent these things are. And they just show up in tons of places. Sometimes they're, you know, two comparisons. Sometimes they're someone trying to be efficient and trying to do, some subtraction in one. Sometimes they're using bit manipulation tricks, and sometimes they're not. They just show up everywhere. So my proposal is we add these to char. Um, and then I had suggestions. We also do the same for hex, and we have multiple kinds of those show up. Sometimes it's just, is this a hex digit? And sometimes it's trying to constrain it to just being uppercase or lowercase. And then finally, sort of the hammer of, I just want to know if something is between these two character values, and so it is in range.
So, this in general looks good to me. However, um, Unicode specifically differentiates and has two properties for hexdigit. It has hexdigit and ASCII hexdigit. And the differentiation is whether or not it includes the full width form, um, which is the, non-ASCII 0 through 9 and A through F. So I think that for completeness and parity, this should be is ASCII hexdigit.
Yeah, I agree with Tanner's feedback there. Also, is in range, I know, is an internal method that we have right now. If we made it public, I'd probably prefer for it to be like is between.
Okay.
Just it flows a little better, I think. But I'm not married to that wording. I saw Jeremy's
Well,
grits.
the trouble, so between, to me, I don't know if we've used it in API before. To me, between implies bookends and therefore exclusive. And the proposal here has them both as inclusive, and so ranges read the parameter names, and between is like, yeah.
Well,
Is with it.
range range from system range kind of has an existing defined behavior of inclusive start and exclusive end.
I'm aware that that is a type that exists, and therefore one can compare things to it. But in my mind, it does not exist. So I just hear white noise right now.
Would is within speak to that? Would is within imply inclusive rather than exclusive?
No, and I mean, like, I'd be okay with between too. Just my instinct on between is that you couldn't ever get true for 0 because you couldn't represent it. But if we called it is between and called it inclusive, it's self-documenting. It's just English is weird.
So we do have time only is between, which is inclusive start, exclusive end.
Of course we do.
Notably, there have been, as part of generic math, people have asked for an is between method. They've always, when I've seen it, been referred to as between. I have not looked in depth into whether they consider that inclusive, exclusive, or mixed. But
we also have sorted set.get view between, which I'm 90% sure is inclusive on both ends.
All right, so we use many words for many things, and everything means everything. Okay.
I agree with Jeremy on this, and I think in dates it makes more sense to make the but between, because the upper range is exclusive, and that makes sense in that particular scenario, because I don't, like, an example, want to check if something happened between now and end of the year, say, but not on the January 1st, but it's easier to type January 1st, I guess. And that probably makes sense in most of the date time scenarios. While in here, I pretty much always would want to have inclusive range, which in range sounds better to me.
I personally prefer is between. I think it's the more common and standardized across various languages, programming languages, that is.
The parameter name does say inclusive, so I think it is obvious to somebody calling the API what the behavior should be. Also, if you imagine that the typical use case would be is between A, comma, Z, that does make logical sense. That doesn't mean A through Y, it means A through Z.
Yeah, again, just when reading the code, I feel like it would be one of those that I have to adapt my brain, because when reading it, it's is it between A and Z? It'd be Q, yes, and Z is not. But I'd be but I think I know what this line of code wants to do, so hopefully it does the right thing. Let's just test it with an A.
Right? Yeah, and that's the thing. When you're reading it, and unless you're paranoid, you or me or someone else, where we worry about edge cases, somebody just writing and reading the code would know exactly what the line does, because they would just assume the simple definition, and it would read fluently to them.
So Python has between, which explicitly takes an is inclusive. Well, they just call it inclusive, but they take a parameter to specify which one it is.
Yeah, I don't think we need to go that far.
And by the way, we have that indexers with the range. Perhaps maybe we could add something like that in C# instead of this API. So basically, when you could say in range and then provide the dot thingy. Just
A dot Z.
I mean, the trouble is you can legally write is in range A dot dot hat Z, and that has literally no meaning. So I don't think system.range would be a good type to use here. It may allow for some nice syntax, but it also allows for some extreme nonsense. Also, it's defined as ints, so you'd have to cast your chars. All right.
So was there any strong pushback for is between? And I'm also totally fine with saying, like, if min inclusive and max inclusive don't make sense with respect to each other, that the API has undefined behavior.
Yeah, the way I prototyped it out in that commit was basically saying it's, there's no validation that max is greater than or equal to min. If it ends up being less than, it behaves as if it, wraps around. So you get weird results, but they make sense.
Well, because assuming that the implementation looks like your comment here, it seems like if max is less than min, it would just always be false.
The implementation right now looks like I minus min inclusive cast to uint less than or equal to max inclusive minus min inclusive cast to uint.
Yeah, this API really, really, really wants you to pass in constants for those last two parameters. If you don't pass in constants, the performance will be not good.
And yeah, I assume, especially with I assume that most of these are just going to get turned into inlines.
Yeah,
that would be the hope.
All right, so Tanner.
Not as a blocking point, but just as a more meta question on: do we feel I should bring forth a proposal for is between on iNumber?
I think it would be fine to bring that proposal forward.
Okay. Yeah, I had seen requests, but I hadn't figured that it was worthwhile enough to do that, given the other APIs that were on there. But if we're already considering adding it for character, just because of how commonplace it is, it's definitely commonplace for other integer types as well. I know we do it all over the code base. So
yeah, and I've also seen real world applications do things like if integer is they allow integers between like -1 and 100, so they could use an API like this.
yeah, okay, I'll take my own action item to bring forward a proposal on that for generic math.
One last naming question. I decided to suffix the lower upper, even though it doesn't read as nicely, because then it sort of nicely groups with the other methods. Rolls off the tongue better as is ASCII lower letter or is lower ASCII letter or something like that. But I decided to have it be is ASCII letter lower, just because then it's sort of logically nice with the other is ASCII whatevers. Do people agree or not?
I don't have a strong preference one way or another. We do already have APIs is upper, so if you wanted to make ASCII a suffix, then it would be grouped with is upper ASCII letter, and that would also make sense to me. So that is all to say, like, I think people will find it regardless.
You could potentially, so I actually kind of like the is ASCII digit lower type format, but if we wanted to keep this ordering and we thought that that particular phrasing was odd, we could do is ASCII letter and upper, which would then imply it's a combination of is ASCII letter and is upper. Just more efficient. But I think the current is fine. Just wanted to throw out a potential disambiguator.
I think the current is fine because the is ASCII and letter or digit would be even more confusing. Now feels fine, and then the and or combination would be like kind of weird, I guess.
So just to devil's advocate here, Steve, I feel with the tar APIs, we'd use the like tar entry GNU, tar entry POSIX, etc. And that you objected on that one, but you're using that style here. Can you explain the difference in your head?
Yeah, for types, going back to the beginning of .NET, we've always said that derived types use prefixes.
Okay. So type versus method. That's fair. Yeah, I mean, I feel like probably most people who are doing anything with hex want hex digit, and then letting upper and lower sit right next to it in IntelliSense is good. So I like it the way it is.
Okay.
Any other commentary? Sold.
Well, I thought it would be only 3 minutes.
Well, we got more people during the time we were talking about it, so that's good. All right.
So Tanner had wanted to go,
Yeah, we should
and
probably
there
talk
was
about
JSON
Tanner's.
work.
What is your issue, Tanner?
The second one, determine recommended behavior.
Okay. All right. So we talked about this last time, but we ran out of quorum because it had gone into overflow, and so if you're caring about the JSON issue, that's why this one's getting to jump ahead.
Yep.
Tanner.
So the basic premise here is that for the past 20 years of .NET, there's been no possibility for users to define their own checked operators. And so whatever operator you defined had one behavior, that behavior was it. And so regardless of whether you were in a checked or unchecked context, it would either always throw on overflow or never throw on overflow. So for example, big integer, unlike the other primitive types, if converting a big integer to an int won't fit, rather than truncating like a long would, it will throw. And there is no way to change that behavior. As of .NET 7 C# 11, we're going to have the ability to define user-defined checked operators. And so we need to kind of make a decision on 4 types, especially numeric-like types. But this also extends to potentially other types, such as date time, where users may want or be interested in another behavior, how we would expose and support checked and unchecked operators. So in particular, there's kind of 4 basic options. The first is you don't implement the generic math interfaces on these types, so you make no changes at all. That's feasible and reasonable for some type like date time. That's less feasible for something like big integer. We can leave the behavior as is, effectively saying that both in a checked context or in a generic context and when using the concrete type directly, the behavior matches whatever the type is already doing. So for big integer, that would mean that it always overflows. We have the option to implement the new operators explicitly on the type. What this functionally means is that when using the concrete type directly, that is, you have a concrete big integer and you convert it to an int, it would maintain the existing behavior. But when used in a generic context, it would match the new generic context, and it would, for example, throw in a checked context, and it would truncate in an unchecked context, matching how the other primitive integer types and conversions work. And then the fourth option is that we could change the existing behavior to be non-throwing in an unchecked context and to be throwing in a checked context, which means that users get consistent behavior between the concrete type and the non-concrete type. Notably, we chose option 4 in the context of int pointer. That is system.intptr, because that matches what the language keyword inint does, and so we were willing to take the breaking change there. The most notable thing is that for conversions, we don't define generic math operators. Instead, we expose explicit create methods, which provide checked, which is overflowing, truncating, or saturating behavior. And the user gets to explicitly pick which of those behaviors they want. The reason that conversion operators are different there is because the number of interfaces required to cover the full set of conversions to primitive types is enough that it hurts the JIT, and so we don't want users to do that. We don't want users defining 20 to 30 conversion interfaces on their type.
Like, does it even make sense to do unchecked for the date time? Like, when would you even want that?
For example, you might have a time only and you want it to wrap around from midnight to midnight rather than overflow when you pass the midnight boundary. While in
Yes,
another case,
the time only I can see, but the date time or date only, I just cannot like I don't even know what would return. Like a big bang kind of time or like what? I don't know.
there's generally two behaviors types have in the case where they don't throw. That's either that they saturate, which is they clamp to a max value. That is what, for example, float, double, half do. And then there is you can wrap around, which is what int, long, byte, and other integer types do, which is they wrap from max value to min value. And so you kind of have two options of behaviors you could do. For time only, I would imagine wraparound makes sense, whereas for date time, I would almost imagine that saturation would be the more desired behavior. And it's possible that some of this is type specific. And so the most impactful thing in the case of generic math is what do we do for decimal and big integer, which are two types which currently always throw, where users, where them being numeric types and being used in non-generic context, users may want to now support both explicit overflow or explicit non-overflowing behavior.
I think this should be like checked case by case essentially, because like in my opinion, date time should always throw like or date only. Like I just don't see like why clamping to the arbitrary pick time would make any sense. For the time only, it totally makes sense. Like 24 hours, it's at least for a long period of time. I'm assuming that's going to be true, but. Yeah, like big integer, like I didn't even know it could overflow, to be honest. Like I also don't see that, like I always thought it was limited by the memory, to be perfectly honest. Like I
So for
I don't even know what it would overflow from and to. Like I just don't have, like I could see, like if you defined like modulus or something, that would make sense to me, but otherwise I would always throw anyway.
big integer isn't overflowing for addition. That becomes an out of memory exception. It doesn't overflow, it runs out of memory. The overflow case for big integers, you're taking a big integer, which represents a value larger than int.max value, and then trying to convert it to a 32-bit integer.
Right, but as you said, that's not the casting operator. That's or that I mean, you're defining the casting operator, but that's not what's being discussed here. It's only the because I don't think we had checked casts, did we?
Yes, the C# now has the ability to define checked cast operators.
Okay, I thought we were okay. I thought we were only getting it on the operators on the symbols.
So C# defines the ability to declare checked casting operators, and int128, for example, is going to define these. They are not available via generic math context. In the generic context for conversions, you have to use the create APIs, which expose all three behaviors you may want. And so this general question comes down to, for the mathematical operators, such as addition, if a type has an existing behavior, for example, int pointer was always was never overflowing today. But in the future will correctly overflow in a check context. Or for in a non-generic context, if you're trying to convert big integer to an int, should we enable the ability to do that with the breaking change that a user in an unchecked context would now not get an exception where they would before.
Yeah. So if we're looking at the places where it's a generic interface is pulling it in, which I think eliminates the checks because that's the casts because that's the convert methods. But I think the answer is the people who can't even see that there's a generic interface have no way of getting it back. So if you're building against net standard, there's nothing you can do to say that you want the old behavior, which means that for is out of the question. Like int pitter got handled differently because we just said fine, it's no longer a type, it's the same as inint. That wasn't we were making a decision on the operator. It wasn't really it was influenced by generic math, but it wasn't like we didn't make the decision to change that type. We made the decision to say that the aliasing was now pure, and we went more the numeric side than the classic "thou shalt not touch this type approach." So I don't see for as being viable at all. It's just
notably for for, we've taken significant breaking changes between net standard and net core for several places where that's an overall better behavior for .NET moving forward. For example, with formatting and parsing behavior.
Case by case decisions, etc. But having as the general proposition that we had an addition operator, and it was throwing. Now that we can express the difference between checked and unchecked operations, we should do that only in the checked operation. No, I think that we should say it does what it does, unless we want to make a specific decision on this one case-by-case basis that we want to take the breaking change. So that means that the default behavior, in my opinion, would be 3, is if a generic interface says we're gaining a checked and unchecked addition operator, we can now make those behave according to what was specified by that interface. If you're doing an unchecked addition as using this type as an I number, then now you get unchecked behavior. And if you're doing checked addition, you get checked behavior. If you're using the type concretely, you get whatever the type has already done. To me, that's the only good blanket statement we can have. And then anything that's different becomes an explicit, like that we write down, hey, on system.foo, we have changed the addition is now an unchecked operation because, well, it seemed like it never came up and it was costly and whatever reasons we wanted. But I don't think that we should take for as the blanket policy.
Okay. Then if we take 3 as the blanket policy, there's the question of for the 2 specific types in generic math that are impacted, which are big integer and decimal, which currently always throw today. Should they be updated to be in line with the other integral types provided by the BCL to correctly support conversions in a checked and unchecked context?
Well, but for big integer, it's casting a big integer to an int, which is the cast operation, which means it's not a generic math operation.
Correct.
So don't change the behavior. It's not even described by the interface. That's a thing big integer does.
Right, which is a broader question of should the type change the behavior to support the new functionality, support the full set of functionality of the type that's now available to be described by the language.
I think somebody who's on new .NETs and wants it to do truncating or saturating can call the generic math, or if we expose it directly on the type, they can call it directly. Anybody who's written the code that wants it to throw, it is depending on it throwing, like they're massively screwed by that change, and I don't see any way that it would ever be considered worth it.
Okay.
That's my opinion. I would love somebody else to speak, but
yeah, I think people can use the modular percent operator. I don't know what it's called for the negative numbers, but the people can use the modulus operator if they want to enforce any kind of overflows. Then not
modulus is not a well-defined operation on most types to
no,
determine...
modulus is very, very well defined. The percent operator is not.
Which
True.
means that that is not defined for the user in what happens. In fact, .NET doesn't even expose modulus; it exposes remainder.
Yeah.
Uh,
No, but it's
I,
people with the current API, if they want the just give me the bottom 32 bits, they figure a way out to get it. And the people who say, oh, I did some math with big integer space, but the result probably fits in the int, just cast it to int and are depending on the overflow when it fails, like that is going to be very hard for them to figure out where they're getting their subtle bugs.
I'm wondering if the right answer might be one. Um, I think it was really good that we explored the generic interfaces with these types in mind because it helps to make sure that such types could implement the right subset of the interfaces. Do we have scenarios though where we're actually expecting people to use datetime with an API written accepting the generic math interfaces? I'm wondering if maybe the right answer for .NET 7 is they just don't.
so for datetime, we could just say that they don't. But for big integer and decimal, that's a non-starter.
Yes, no, big integer and decimal, absolutely. So
Yeah.
I'm specifically thinking of datetime.
Yeah, sorry. For date time, I agree, and I think it can't even meet the constraints because at least it can't be like iNumber because number has to be additive to itself, and date time
Well, that's what I meant
is
about
not.
some subset. I don't think it's implementing iNumber. It's implementing some other subset of the interfaces that Tanner defined.
Yeah.
Right. It implements addition operators, min-max value, and subtraction operators, allowing users to theoretically use it with, for example, a link sum, or some other basic mathematical operations which work only over addition or subtraction.
What does it mean to sum two date times?
Exactly. So it would be a sum of time spans into a date time. So date time, the addition operator is date time time span returns date time, and so you would define, just as you might define summing an int array to return a long, you might say I want to define summing a time span array to return a date time.
Right. Yeah. Sorry, you cut out. My headphones are being wonky. You cut out for part of that. I totally understand adding a date time to a time span, but I didn't understand the idea of like enumerable.sum this list of date times.
No, you wouldn't be able to sum the date times. You would sum the time spans into a date time, just as you would sum an array of ints into a long.
You would sum time spans into a time span, which you could then add to a date time.
Right.
So what
or
date
if
would
the sum method.
So what date would you return if I added 3 days to 5 days to 7 days?
Exactly whatever that would do if you added time spans today and then added it to datetime.0 or default
Right.
or whatever.
Adding time spans gives you a time span. It's just you would then need to have the baseline date time to get back a date time.
Yep.
Yeah, I mean,
So I guess I'm wondering if like for I don't know the whole list of types we're including and similar types here, but maybe we should explicitly spell out which ones we're talking about, and some subset of them probably shouldn't implement the interfaces at all, and for the rest we should decide what we want to do.
Yeah, that would be date time, time span, time only, and date only. Also, GUID implements the equality operators, and ispan parsable. I imagine ispan parsable should just be kept on these, even if we remove the mathematical ones.
Yeah, I think so as well.
yeah, I think the things that are, trying to be mathematical fields. So int plus int goes to int, where we can say you're additive to yourself. All the things that do that, having the interface for the operators makes sense. Anything that looks like a number being a number makes sense. I don't think I'd bother putting the date time has an addition operator unless somebody had a compelling argument for it. So
Okay.
Basically don't, like, we could declare it, but we're really declaring it just because it duck types as it, and so I think we should wait until there's a use case.
Yeah, that would be more convenient than real mathematical operation.
And so I guess I agree with Steve of the types where it feels unnatural. The answer is don't implement the interfaces. But when we get things like if addition is a checked operation on if decimal add is currently checked because I feel like it has a maximum amount that it can support, then it should stay checked unless you're using it in a generic context. Is my opinion.
And so it shouldn't do the same change that int pointer is getting, inuit pointer are getting.
Right, because we've previously said, not entirely consistently, use int pitter only to describe void star and don't use it for math. And people used it a bit for math, and now we're finally saying, fine, it's the same as native integer. Do whatever you want. We don't care. Don't use int pitter as a void star. Use a safe handle for a void star, or just write unsafe and say void star. And so int pitter got a special. We're throwing up our hands and letting stuff happen. We're not saying it's conforming to generic operations. In my head, that's the model.
Okay.
So, but decimal
and
is
so,
old as time. The people who use it and want it to work the way that it has forever. So,
and the same for big integer, you're saying?
yeah.
Okay. So that leaves our default stance is 3 for date, time, time span, date only, and time only. We'll remove everything but ispan parsable. The same goes for GUID. That would also mean removing iEquality operators from that, which seems reasonable. The users can just use iEquatable. And then of all the actual numeric types exposed, the only two that are somewhat special from a non-generic context are decimal and big integer, where they will always throw on overflow. And if you want the non-throwing behavior, go into a generic context.
That sounds good to me. And apparently, we're the only two people here.
Just to summarize, that's basically some things fall into category 1 and some things fall into category 3. Is that right?
It's that for the types that don't make sense as numeric types, so like date time or GUID, we're not going to expose any of the operator interfaces.
Right.
We're only going to expose ispan parsable. For
Right.
the
Which
things
I don't
that
consider
are,
to be I don't consider that to be math. That's why I was.
which is also why we kept it in the system. iEquality operators is math related, whereas if you want non-math related, you use iEquatable. So for non-numeric types, they're category 1. For math and numeric types, they are category 3. And that's the behavior that we'll push forward unless there's some extenuating circumstance to do 4 like int pointer is. For the first bullet point, could you put in parentheses there just the new interfaces under system numerics namespace, since that's the differentiation between how they're exposed?
Better?
Yeah, this sounds great to me, and I'm glad we came to a good decision here.
I don't even know what to call this. Approved?
Yeah, I think it's approved.
It's
Decision
with-
approved.
approved
Yeah.
means decision final. So
Yeah.
okay. Thank you, Tanner. All right. Developers can customize the JSON serialization contracts of their type 63686.
Hey, so scroll down to your conclusions from the last time. Maybe I think everyone. I think everyone here was here last time, so we don't need to recap here. Yes, so there are a couple of things on the list we've put here, and a couple of things I had to. We've kind of talked with Eirik, and we kind of don't think they might be good things to do now. So first of all, let's start with the complete object thing proposed. So we don't think this is a good thing to add for now. There are a couple of reasons for that. So first of all, Newton's of JSON doesn't seem to have any similar API. Second of all, that would require us to do a lot of refactoring in the code, which would decrease the perf in a really bad ways, because there are some certain assumptions we do in the code which make it very weird if we've added the complete object for now. Also, this is like one of those APIs which we kind of we don't think they are needed as the first thing, and the only actual example we could really find was the immutable array and things like that, and we plan to address them separately in different issues. So we kind of think this is not good for now, at least API. Like we might want to consider that as a future improvement, but as the first iteration of those APIs, I think it might not be not be a good decision, I think. So I've heard some like really strong opinions on having this last time, so I'm gonna stop here and wait.
Well, one of the things that would be important, even if it's not added now, is could you add it in the future? So the particular thing with this one is that it needs to allow the type to change between those. And so if anything right now is the type from create object is the thing and is the only thing and must always be the thing, and that's a absolute limit, then how would you support this in the future? And if it requires building a thing exactly as complicated as this on the side, then it's not worth it.
Let me tell you. So yes, with the current proposal, without this API, it's actually possible to most of the time support immutable array. So if you're not deserializing immutable array directly, you can do it through the property setter. And so basically for any case which is not exactly immutable array, you can pretty much do it. So like if it's a property on the class or something, you can do it now. So you basically change the setter in such a way that when you set it, basically, so you in an example, you can do it so that you deserialize the list, so you mark the properties as a list, and when you do the setting, you convert that into the immutable array. So that's like one way to do it even now. And in the future, like, yes, it's possible to do it, but it would, yeah, like let me say it, it would be a huge chunk of work inside of the current implementation to support that for now.
I
Like,
think to
properly.
add to Christoph's point, the reason why we wouldn't want to expose a complete object delegate as proposed, as in a thing that kind of swaps the runtime time on the runtime type on completion of deserialization, is that this would never possibly work with POCOs, as in when you're trying to deserialize types that have property accessors, because property accessors, specifically require that the runtime type precisely matches what you're trying to deserialize. So this would be a gadget that would only work for collections. We think, well, I think that in the future we might want to add functionality for parameterized deserialization based on parameterized constructors, and in that case you would basically just pass an argument to a constructor that would build the immutable array for you, rather than swapping out the underlying thing you're building.
Well, I mean, maybe I'm totally not understanding how the thing works, but it feels like it's that you should be able to build a type resolver that says I will build an immutable array. And what that would mean in the case of complete object is complete object returns an immutable array. But create object in the middle returned an immutable array builder, and then all of the adds got called on the immutable array builder, then it calls complete object and gives you the immutable array, and that's what gets assigned into the POCO that had an immutable array of whatever. And
I think the question here is like, what if you, instead of creating the immutable array builder, you create, say, I don't know, like any class basically, any class, and then what does complete object do, and what do you call on the?
well, it's complete object would have to return the type of whatever the type resolver thingy says it's building.
Yes, but like, what do you do about the properties of the builder type? Like, do you serialize them, deserialize them basically the same way, or like using the builder type and then call the complete object on the builder still, or like just basically, like, we feel like this is applying mostly to the collection types rather than POCOs. Like for the POCOs, it just feels weird.
I mean, in my head, it would be you get back a thing from create object. That's what you call all the setters or adders or whatever on, and then you call complete object when you hit close square brace or close curly, whichever one's appropriate. And then that would also be the same place for the people who I want to throw if they didn't specify these three properties, or if they specified this one without these other two, and like that would be the natural place to do this. It's the object is done, whether it's a collection or an object.
So I would say that complete object as a construct is probably mixing two concerns. One is on deserialized callbacks, and the other is kind of swapping out the underlying thing that is being deserialized. I suspect that these two would need to be kept separate, and we want to add support for on deserialized callbacks, absolutely, but you wouldn't be able to swap out the deserialized instance, obviously. But on the other hand, to unblock handling of immutable structs or immutable collections or anything like that, where you're not actually able to populate the thing with elements or set things into properties, I think that we would essentially need to surface different constructor delegates for each of the JSON type info kinds. I have produced a provisional list in a comment right below yours in that thread, Jeremy. But essentially, that would effectively. So I have a bulleted list. The idea is, and of course this would be implemented in a future iteration. The idea is that you would have a func taking a nihilist into an object for building immutable structs or classes that don't have setters. A func that takes iDictionary for building dictionaries out of deserialized JSON objects, and so I actually flipped the order. So the first one takes an nihilist for populating collections, and a func that takes an array of objects for constructing POCOs structs or classes. A caveat to the final delegate is that we would need to surface a concept that is currently internal in system like JSON, and that would be JSON parameter info. So effectively, we'd need to let the user model the parameters for the constructors that are being called, so that they get deserialized appropriately. But that being said, the current iteration offers no way of deserializing immutable collections or immutable structs.
Fair enough. Yeah. So really, my point on it is that if it's being removed and it's being removed with the notion of we could always add it later, the question is, could you really? And
So I can
could the
think
scenario at least be solved in some other way?
Yes,
later.
it is possible to do it, and I can even think of a simple hack to do it really quickly, but I don't think it's a good idea to do it now. I think we might solve it differently if we think about it holistically with other APIs. So I think it might make more sense to wait with this API and see like how it plays out with the other things we're planning to add later. But as proposed, it would be technically possible to do it, but at the same time, I think it's better to wait and design it with the other APIs in mind.
Anybody else have anything to add on that point?
No, I should say, like, I think I'm the person who brought it up originally the last time we reviewed this, because I was calling out what other serializers did with regard to things like iObject reference and the ability to swap out types on deserialization. If you are convinced that it can be added later without breaking people, without breaking the API, then sure. Like, I don't think anyone has been asking for this yet. It's just if we do have a long-term plan to deprecate certain serializers, binary formatter, for instance, and we want to promote this as a powerful replacement that has a lot of the functionality that people needed from it, I think we will eventually need to address this point.
I agree. Yep.
Okay.
So we all agree with it's fine to not add this now, right? Okay. Next thing. So the second largest thing on the list you wrote there, Jeremy, was the combination patterns. I believe that was the only blocker here. So I actually added the doc on the top issue. If you search for, let me search what you search for. Something with the combining resolver. Oh, I mistyped that. It should be combining resolvers. Open the doc basically, and that I went into the a bit of a stretch here. So I've started looking into how people do that with Newton's of JSON. So my conclusions were basically following. First of all, I initially said I haven't found a single place where people combine resolvers. I found one Stack Overflow issue where people ask how to do it, but in the specific case where they've done that, that was a very simple thing they could have achieved with a very simple inheritance provided by Newtons of JSON. But anyway, the conclusions here are like people pretty much never do that, almost. The idea here is most of the people do it through such a way that they derive from the default JSON resolver, JSON contract resolver. Anyway, they derive from that. They change really simple behavior and then just use that. Like I haven't, like I only seen like one Stack Overflow trait when they wanted to do the same thing, but they also were combining with, rather than default contract resolver, they combine it with the, I believe it's called the camel case resolver, camel case property name contract resolver, and they just wanted to change one simple behavior with that, where they basically could also basically inherit and change that behavior. So I haven't found like anything where people actually needed that for really something really advanced. something like, I don't know, like F# related and hibernate. And the unhibernate case specifically seem to be like very simple as well. I actually pasted 2 examples of how people implemented that. It's on the first list under unhibernate. There's example 1, example 2, and they are both almost exactly. It's on the top. They're both almost exactly the same. Basically, the idea is that they use base type when they paste the lightning. Yeah. The second one is probably easier to see. Yeah, so basically this is what people do on the unhibernate. So basically if it's assignable from the unhibernate proxy, they use the base type contract. So that's the basic idea. Yeah, like this seemed pretty simple, and the idea is like I didn't find strong enough usage of people needing combining resolvers. So I proposed like 3 variants here. Basically, one is like we don't do like, so if you scroll down, I wrote a couple of samples I found on the internet using the so basically I found the scenarios people do and I implemented them here. So I've shown like 3 variants basically how people could do that. So basically in the first example we don't introduce any combining patterns. You just basically implement the class yourself and then you change whatever behavior you need, and that will solve most of the cases I found on the internet. Like I'm gonna almost say yeah, every example, but I didn't search the whole internet, so I searched only chunk of it. I've done this GitHub searches. I've done the Stack Overflow searches. I've done basically what I could, and I couldn't find a single case where there was a complicated enough case where you couldn't do that through simple inheritance and basically. So the second variant I proposed here, we do the simple combination pattern on the default JSON type info resolver. So we don't do anything crazy. We just simply provide 2 methods on resolving type info, which is basically allowing you to provide the fallback logic, but kind of like a reverse fallback logic. You start with the type info resolver passed in, and then if that returned null, then we come back to the default JSON type info resolver logic. And then the other one, which is actually more common, and I would say 95% of the cases I found was only would need the second the unresolved type info, and that is basically just modifying the JSON type info, the default JSON type info resolver returned. So I think that this specific APIs would solve like every example I could find on the internet, and there was nothing crazy. And the advantage is using something like as simple as this is that it also enforces good patterns on the library authors. So like in the first variant, like if we allow people to inherit and like we will allow, but because we provide the interface, but like if we make people provide their own class as the resolver, that basically creates it so that if people really want to combine and they find themselves like in 5 or 10 years that they need to combine, then there is already a bunch of classes on the internet and they are not really combinable. Because they encourage not returning null for the get type info. Like on the other hand, if we provide variant 2 or variant 3, and variant 3 I will get into later. So variant 2 like kind of enforces like how do you write resolvers. So which we don't need to modify. You would need write any method basically which takes JSON type info as the argument and returns nothing basically, and that enforces the really simple pattern so that people basically don't inherit. They can just write a simple lambda, and also if they write their own resolvers because they need to create the contract from scratch, they would also we could also encourage them to return null for cases where they don't know how to handle, and because people would be advised to combine it with the default JSON type info resolver, which probably 99% of the cases would be the default fallback logic for them. And and I think that is a kind of like a really good middle ground between variant 2 and variant 3. And the variant 3 is what we initially proposed with Eric, which is the full kind of known combination patterns, and there are also 2 APIs, happens to be, but they are maybe not like they are both simple to use, but this one doesn't feel necessarily as trivial as the first one, as the variant 2. So basically, this guy is basically you can combine any 2 resolvers in any way possible. So you write your own resolver. So you can take like a context, basically serialization context, and do the fallback logic to the default resolver and or whatever else resolver you could have written. And the callback would basically be essentially the same as the on resolving, which is the thing on the thing which basically modifies the contract. So they kind of both provide similar APIs. This one, like I like both variants, like 2 and 3. The 2, like let's start with the fact that like looking at the usages, basically there's not strong enough case to in usage terms to add any of the combination patterns APIs. But given the fact that the combination pattern APIs enforce better patterns for users, I think it's a good idea to add such APIs because of that, although I think they will be very rarely used. So it's basically between like I think it's between choosing how much like flexibility we want to give to users, and basically you have to look at the examples on variant, like how the variant 2 and variant 3 would be used. And I've seen the variant 2 is probably something similar they would do with the Newton sub JSON. It's probably be easier to transition for people, even though the Newton sub JSON doesn't provide the combination patterns. It's still, I've seen people lots of time casting the type info resolver to the default JSON type info resolver, because that was what was used like pretty much almost always. And yeah, like, and the combination patterns, they are fine, but they also they have like I guess the perf isn't a good good trade-off here, because this thing is called once per type per options. I guess that's the perf really doesn't play that much of a role in here because we do caching and stuff. So I guess it's the matter like of how much flexibility we want people to have. I think it's good to provide some combination APIs because it enforces good patterns, but that is the only reason the usage doesn't strongly say we need them.
So my recollection is that the thing that we really needed to combine was the stuff produced by the source generator, and since there aren't source generators for any existing libraries,
Whoops. Hey, you're back.
did you boot me?
No, you exited the chat. Are we still streaming, by the way?
The stream's still running.
Okay.
Weird. Yeah, Teams just made a disconnect sound, and I wasn't. Yeah, have no idea what OBS latched onto when the window closed. So, hope nothing bad got streamed. Yay for fuzzy matching. Anyway, my understanding is this is related to the source generators producing context across multiple assemblies, and since there weren't source generators previously, you won't find prior art. So you can't just say no one does this, because no one does this. But we now have this plus source generator coming together, and the question is, how are those going to work together in practice? It looks like that got talked about in your sample for 3, because I understand.
Jeremy?
Yeah?
I think you might not be sharing your screen anymore.
Yep.
Oh, okay.
Yeah. OBS is still working. Like I can
Yes,
still see
YouTube
the
can see
stream
it.
is correct. Yeah.
So like I see in the sample for 3 that it talks about the bar context.default, which I understand that to mean the source generator was involved. But like honestly, I don't understand what these are doing at all. So maybe variant 2 solves it, but these words mean kind of literally nothing to me. So if people like that, then we'll get to talk about that one. But the whole point of we can do nothing because JSON does, or Newtonsoft JSON doesn't, I don't think really applies.
Yeah, like I agree, like we should provide combination patterns, because if we don't, then people will start going wild and we will have really incompatible stuff like in the future. That's my guess what's going to happen. I don't really know if that will happen. But yeah, I kind of have a very strong gut feeling like we should add something, because this way, like we will basically have a good story like to tell in ways like, okay, like when you don't know how to handle something, return null. And like if we don't provide any combination APIs, like then questions are like, why would I return null? And the serialization context actually does return null by default, unless with some exceptions, which are really weird. And I think we're gonna do some breaking changes in there, but that's kind of separate story. But in general, like by default, it will return null when it doesn't know how to handle the type, and that's what I think we should extend on. And so basically, in both variant 2 and 3, I actually have shown like how would you use the context with the proposed API. So
yeah, to Christoph's point, like there is precedent in the framework for this. Our existing serializers have a concept called iSurrogate selector, and their behavior is return null if you don't know what to do, and I'll simply call the next person in the chain.
yeah, I think it in the end, like people like will be fine with either APIs we provide. Like, and I think like even the implementation wise, it doesn't really matter that much in terms of even perf, like really, because like this is called like just once per type, and like I don't expect people to have like millions types. I hope. So yeah, I guess the I maybe like, yeah, like I like both variant 2 and 3. I think like looking at like how people used the contract resolvers with Newtonsoft JSON, I'm kind of calmer about like either using 2 or 3. I think like 99% of the cases will be solved by just adding variant 2. Variant 3 is fine as well. Perhaps the serialization context maybe pushes us toward the variant 3. Because that makes it clearer like what order like stuff will be happening with, versus like if you go with the variant 2, it's clear order, but at the same time it on forces we always fall back to the reflection logic, which with the serialization context that might not be a case for the IoT scenarios.
So personally, like with 3 in the way it's currently proposed, I understand what's happening mostly, especially with fallback. I understand who gets called and in what order and which thing's going to win. When with callback gets added in the mix, it gets less clear, but that's fine. But with 2, like you have 2 things that look kind of like events, but they're not events, and they're both void, and so I don't understand what they do at all.
They kind of like register event, but I guess, but I felt like adding removal of the events didn't make sense here, so that's why it was implemented as a method.
Well, because this seems like you're using it as like add type info.
Yes, it is kind of used like that, and basically that was the idea here, and yeah, but basically I just didn't feel like, and like it just didn't make sense for me to add the remove thingy for this guy. because like once you use it once, like this type resolver, like you technically shouldn't be changing it, and this makes it like adding the remove would
Right,
do
I'm just saying, like,
limit
I don't
this.
know what, like, to me, on resolving type info, like, A, it sounds like a type info is being resolved, and B, I don't know what this thing that it takes is and what that has to do with, like, if this is go add this into your context, well, now it's not clear of does that beat whatever the default context would have been, because if it's add, the normal rule for add would be the last one wins or it throws on a conflict. And so it maybe 2 does the right things. I just don't know how to read it out of the methods that are proposed.
Yeah, I don't have strong preference. As I said, like looking at the usages, I think people will most of the time just do this really simple modification, and then basically they will not even think about the combining patterns that much. But like I don't know what will happen with the serialization context APIs, and also we should recommend the good patterns for the library authors, and I think both variant 2 and 3 gives that. Like no combination patterns doesn't like basic enforces bad patterns and by default, and that's bad. So I'm fine with either. Like I guess that will be put into vote in the end. But yeah. So what else? Yeah, and also one thing I found with the Newtons of JSON. So we've previously said we want to seal the default contract resolver. I don't know if that's a good idea. The reason I think it might not be a good idea is because in Newtons of JSON world, everyone is inheriting from the default contract resolver. Pretty much every single example I found is either inheriting from that or the other alternative proposed in the Newtons of, which is the camel case, something long name resolver. And basically, yeah, they inherit and they change something really simple and they use that class, and because it might be easier for people to transit, might be a good idea to leave it unsealed. Although I'm not strongly opinionated on this.
Well, but if in Newtonsoft JSON they're extending it and changing something that suggests there's a virtual, and I believe you had no virtuals.
It's because we removed it as we were sealing it. But the get type info would become virtual if it was unsealed.
Fair, but again, it doesn't seem like you get to, that there's a thing that you get to change a behavior, that you get to do a completely different complicated thing.
Basically that would be equivalent to adding the callback. And like if we provide the callback, maybe it doesn't make sense to have that. Like just don't feel strongly about it. Like if we have the with callback thing, like you basically, okay, I add the callback, change whatever I want, and I call it a day, I guess. So yeah. And I think it will be like, I think the differences between the Newtonsoft and this APIs are like enough that they will still have to, people will still have to think about it a bit, and I guess it doesn't, like, yeah, the action should be sufficient for them. There is no really, yeah, like I think it might be slightly easier to maybe transition. I just think like if people get used to certain patterns, it might be okay for them to keep using them, I guess. Like that's what I say. I'm not strongly opinionated on that. Like perhaps might be a good idea to keep it sealed to basically, and like have a story straight about the, okay, if we enforce the ask people to do good patterns by using the return null and having the default be sealed, that's basically clear story. Okay, you should return null if you don't know how to handle, and the moment we unseal it, like it's okay, like we tell them to return null, but at the same time we allow them to inherit and change stuff. So I guess that there's some ambiguity here, like what we propose. So yeah, like having all that said, so and like hearing your opinion, the new recommendation, which is different from what I wrote in the bottom, is like variant tree and seal the default JSON type info resolver. So I guess Eric, you were very strong about unsealing the JSON type info resolver, default one.
Yeah, my 2 cents are that I think we should leave it unsealed. If anything, because every single custom resolver in Newtonsoft land, like every single Stack Overflow post about how to do things, it basically involves inheriting the default and making mutations to the underlying result. So I think there's value in making migration straightforward here.
And is it the same form of basically call base dot, then modify it, and then return it?
Yep.
Okay, because like just looking at it, it doesn't sound like there are options to change. If it's just one method that's virtual, it's what you want to do is modify the return value.
That's why, in my opinion, like with callback makes more sense to me for porting stuff like that. Like if people want to change it, they can still write their own class. They just don't inherit from the default one, and they just create one method which takes JSON type info and pass that into the callback, the with callback method.
Yeah, and for a bit of context as regards the callback method, and apologies if this has been mentioned already, I missed the previous meeting, but that shape was specifically requested from James Newton King, because he actually wanted this type of pattern to compose like multiple different mutations to the underlying default result without needing to write all the inheritance boilerplate when kind of multiple rules are taken into account. And he actually was initially proposing that we expose this as a first-class citizen, like just something where you subscribe callbacks. But we kind of felt that having the interface and maybe building combinators as extensions, that is probably good enough.
Yeah, so basically the new, James proposed something along the variant two, except it was slightly trimmed down, like only the one method rather than two, so only the modify method. So that would be resolver on resolve type info. It would be the only callback. I forgot how we call it though.
I don't know what questions to ask, so Levi, Steve, I would say Stefan, but he seemed he had to drop. Anybody else want to direct some questions to figure out what we're doing here?
The scenario makes sense to me, honestly, and I commented earlier, like we do have precedent for stuff like this in the framework. We don't really use fluent patterns within our APIs, except for the opinionated extensions namespaces. But beyond that, like I don't really have feedback. It makes sense to me.
I'd say the same. It overall makes sense to me, and I think I agree with what Levi said.
Okay, so does that mean both of you guys think that we should look at what's called variant 2 but figure out the naming involved in it? As opposed to the fluent, we built a type for you and you just don't need to talk about it?
Yeah, normally when we have APIs like this that are void returning and take a delegate, normally we call those APIs like register or similar, because you're registering some kind of action or callback to take place that can manipulate control flow within whatever the consumer is.
Right, because on feels like it's the either a protected method that
like
you
an
get
event.
to override of here we're calling you because we did this thing. Is there something you wanted to do? Or that it's that it should be public event on resolving type info. So like I'm fine with the methods. Just right now, the on resolving and on resolve don't. I don't know what they do and when you would call them. And then what's the ordering that matters, and because the sample here
Yeah, the
says
variant 3 is more readable, but the
beats
variant
bar,
2 is
but somehow this both beats the default, and that seems special.
yeah, the variant 2 has really weird ordering, because that would be first on resolving, like call on all the on resolving method in the order, then it would fall back into the default one if nothing happened, and then after that it would call in order the on resolve, which is all of the actions.
You said that these are invoked once per type, correct?
That's true.
Would it make sense just to make these proper events? Remove the on word and call it, resolving type info, resolved type info?
It could be events, but at the same time, like why would you ever remove it?
Sorry, why would we ever remove? Oh, why would you ever remove the callback?
Yeah.
I heard this word. Collectible assemblies?
Well, presumably that wouldn't matter here, because the info resolver would need the strong reference to you anyway. And if you ever needed your assembly to be collectible, just remove drop the entire object graph that includes the resolver, and then just new up the entire settings world, right?
Yeah, I guess I don't know when this resolver thing gets created and who's hooking it and what. Like, if this basically is a static that people are joining into now, then not being able to remove yourself means you couldn't be a collectible assembly that played in this game.
This is hanging off of a settings instance, correct, Christoph?
Options, yeah.
Yeah.
So
drop your reference to that, and the entire thing's now GC eligible.
Okay, a scenario of why would someone want to unregister something if the resolver object outlives the assembly scope, then that would be why.
That said, we know whether or not we're going to keep making calls into these functions, correct? Like we know when the resolver is effectively dead and will no longer be used, correct?
No. Basically, as long as the options are alive, it could be used.
Because you could pass a brand new never before seen type to it?
Yep.
I see. Yeah. Because I was going to suggest, like, once you invoke all of the callbacks, you could just drop your own reference to them, but you're right.
But on the other hand,
fine.
the resolvers are supposed to be very cheap types. It's supposed to be just like one method. There's
right,
no
but
state or anything.
But in the scope of, I don't actually know what all is involved in collectible assemblies, but in the scope of a collectible assembly, it feels like if a resolver object is being held by something that outlives the lifetime that you expected that you would even need this assembly to be loaded, that now that's it's keeping a type ref alive into that assembly, so the assembly can't be collected. So it was a small object, but it ends up having a we can't unload things now footprint. But if the resolver itself would be temporarily used and then GC'd, and then now you've lost all of the references into that assembly, then sure. So it's a lifetime question.
Yeah, technically, in the future, if we find this as a problem, we could possibly, like, I don't know, maybe introduce something like I don't know about the name, but something like disallow resolving or something like that on the options, and then that would make sure that the resolvers will never be called again, and that way you can collect them. But this is I don't know how would you call it, but essentially that would yeah.
But the precedent for that is to name those methods bake. I'm not joking.
It's hard to believe you, but I believe you.
Yeah, like So, if this is, I don't know, add external resolver, or whatever, then this loses over the third option, loses the ability that something encountered later gets to go to the front of the list. So if this is the first thing added on this call is now always the first thing consulted, you've lost some ability to intercept things. Granted, you could do it here and yeah, I guess you could do it as the late thing and then just completely rewrite the JSON type info, but you couldn't. You'd have to copy over top of it. You wouldn't be able to replace it.
Or just expose it as an IList and let the caller manipulate the order however they prefer.
Yeah, basically, like if this was a property list of JSON type info resolver external resolvers, then they can call add, remove, insert, etc.
That would be, having it as a list, I think, would be the most powerful in the sense that you control your own ordering. Because normally systems allow you to specify an ordering as an integer when you call register, and if you want to go first, you're expected to pass some really big negative number. But honestly, I would always find it easier just to say, like, list.add first or something, or list.insert 0.
Mm-hmm.
Fine with me. But you mean list or iList?
Why would you be an iList?
Whatever.
Yeah, I prefer list. That's because the iList is like really missing a couple of methods which are really useful.
It's
we might want to consider iList just to lock the instance after it's been tied to the options instance and the resolver has been invoked for the first time. And that's why we're servicing iList in some other things in JSON serializer options.
Okay, yeah. So if you're going to use a custom type so that you can, mark it as it's now read-only, then that would make sense. But if you're going to, if anybody's ever going to be able to take the property and successfully hardcast it to list of t, then just make it list of t.
Yeah, I think we're gonna have to be locking. Yeah, so I guess iList. It's not my favorite type, but it makes more sense here.
Yeah, iList does have an insert function, so you could always call, external resolvers.insert 0 my callback.
Yeah, I absolutely don't like the fact that it doesn't have a remove all and things like that. And
you mean clear?
No, the remove all with the callback. The predicate. The predicate.
Oh, I see. Yeah. I mean, that could be written as an extension method, though, for anybody who wants to do that. But yeah.
All right. So, what do we want to call these things? Like, what's the name of the property? I made up external resolvers, but that's just because I don't know what I'm talking about.
Yeah, that's a good question. The combination patterns make the naming easier. The variant 3, I mean, this one is harder. Modifiers, I don't know.
Additional resolvers, resolver chain.
So I have a question. So I'm guessing we're looking at adding these methods to the default resolver rather than exposing it as a general purpose combinator. Is that right, Christoph?
Correct.
So what would be the semantics of the first overload, the overload? Well, the first method, on resolving type info that accepts another resolver. And I'm asking this because the default resolver always produces a result. So there'd never be a reason for you to fall back into something else.
It's not a fallback. It's the reverse fallback, like whatever.
So it would be consulted ahead of calling the default resolver. Okay.
I mean, you could always have a static combine method if you had two different resolvers that you wanted to put together.
Yep. And don't get me wrong, the variant tree is not like can always be added later. It's extension method, it will work.
So the resolver chain property is not a chain of resolvers, it's a chain of...
Oh, I copied the wrong.
So my question is, doesn't this thing though constrain the pattern to combining other resolvers with a default? What if I just want to combine two resolvers that none of which are the default?
Then you have to write your own combine.
I mean, doesn't that defeat the purpose of, like, I don't feel that this is generic enough.
But why wouldn't we be able to provide a combined method ourselves?
Sorry?
So, Steve, I think you were talking and I talked over you, sorry.
I was gonna say basically the same thing, which is, isn't the more general construct just providing the combinator for combining two resolvers and the ability to say use this resolver, and then you can combine whatever you want in whatever order you want and say use this.
Yeah, because to that regard, I would think like JSON type info resolver dot combine is a static method, and it takes a params whatever argument, like done. Pass as many arguments as you want to it.
I don't. Is there a JSON type info resolver type?
There's an interface, JSON type info resolver.
Right. I don't. Net standard 2.0 can't have statics and interfaces, I don't think.
I don't think we would want it on that interface anyway.
Well, but then what's the type that would then get it?
We would make a type like JSON type info resolver that
just
has
a static type
helper
that has
methods on it.
So basically that's 3, but get rid of the extension pattern.
Yeah, and then the order in which you pass the arguments is the order in which they get executed.
Yep. I can do this in here. No.
I mean, this also goes back to, I forget exactly in the context we were discussing it, but maybe a month ago we had another one of these reviews and we were talking about such combinators, and we were talking about, like, I don't remember, maybe we didn't even have the default resolver type or something, and you were able, you could have achieved it if we only exposed the combinator, but we decided not to for simplicity or something. Does this ring any bells?
Yeah, like the variant tree is basically what I was talking about. So basically that is generic enough that we technically don't need the JSON type info resolver. But the problem is the fluent patterns, which we said that we don't have anywhere in the framework, and that makes it weird, I guess. But it's effectively the same, except it's a static extension.
Okay, I'm not sure if that's what I was thinking of or not.
But is this basically what you were thinking, Levi?
Yeah, but I would just take params straight up and not even have multiple overloads, but sure.
Yeah, and we could also provide the one which adds the callback as well for the completeness, because like if people might write one, it would be just easier to combine them this way. So basically equivalent of the with callback, but with the static. You got extra R after info.
Why have the first? Is that just this goes back to the concern that you might pass it to 0?
Oh, yeah, I guess it's just
I mean, if you pass it an empty array, it would just give you back an empty resolver, I guess. Like whatever.
Right.
That's fair. I was, yeah.
Or
Or
in
throw.
actuality,
You
it would
decide
probably
whatever you
throw.
want.
Yeah, yeah, because it can't give you anything useful at that point.
Yeah, I guess we can leave the params for syntax, I guess.
I mean, in what real world scenario would returning a zero resolver make sense? Like, shouldn't we just completely disallow that?
Yeah, throwing, like Steve had suggested a second ago, would be appropriate.
Like, what if you expose this through different APIs and you already had a resolver and allowed people to combine it with some extra resolver? They might, maybe something like that. Like, basically, if someone let it through the options somewhere, then maybe it makes sense to have the empty one.
But I guess I'm saying, shouldn't we require at least one argument?
No, because like if say you wrote the options for my, I don't know, like my protocol, and then you add in the options somewhere the, I don't know, like additional resolvers or something like that, and then the user provides empty, and you combine that, like, actually, yeah, then you still would have the first one, I guess.
I'm not sure I follow.
No, never mind.
Like if
no, you're right.
If our combinator produces a resolver that either always throws or always returns null, where would that be useful? Like I would say that we should require at least one argument in.
Yeah, the combine method would throw.
But why though? Like why do we need to support that and add unit tests for that?
What, are you disagreeing with combine not taking a dedicated, like not being two arguments, one that's the first and the second that's a params?
Yeah,
I'm not sure what you're...
Yeah, I would recommend taking a first argument and then a params argument.
The downside to that is you disallow someone from passing. They build up an array and it's hard for them to pass it in.
Sure. Okay.
Do we need the IEnumerable version?
We don't need it. It's just.
I'm just asking because this it doesn't feel like it's a really perf intensive scenario. That's why don't feel strongly about having it, I guess.
Basically, it's doodled as a strongman.
I think this comes down to what do we expect the usage of this method to look like? Are people writing an iterator that produces resolvers to use? Like what? In what situation would you have an IEnumerable of these?
You have a list, and you're.
And you can always call to array in the end, right? Like it's a one-time operation per most of the apps.
Fair enough. Deleting things is easy.
So what's the modify method? That second method on the screen.
The providing action basically.
This is my understanding. Is you want the resolver to go do a bunch of heavy work, but you want to change. It returned a JSON type info where the property name started with a capital P, and you change it to say it's a lowercase p in the JSON.
But you're returning a new resolver, correct? You're not modifying the original resolver.
No, you're modifying
it's implementation detail.
What he had proposed here was using action, so it's modify and not replace.
Yeah, but it's returning a resolver, presumably because this was intended to support fluent syntax. And I'm wondering,
that would actually be returned a new resolver.
It would need to return a new resolver because you.
Yeah, because the first one would be modified.
It's again, this is looking at it if it's the static here on JSON type info resolver. If we say that this is simply a feature of the default type info resolver, then we can do something else.
And I will also suggest to make the second parameter params of the array of modifiers. It's because I assume if people might want to add more than one, and if we're gonna be modifying it and returning the copy always, because that would be technically what we should be doing, because we shouldn't be modifying, like even if it's internal instance, we shouldn't be modifying it, I guess. Because
Isn't that what delegate.combines for?
If you as one author want to modify several types, then you can do that inside one modifier by asking what type it is, or what the target runtime type is that you're modifying. It would only be if
that is
like
fair.
6 different modifier methods wanted to be chained.
I
and
agree.
Yeah, so I don't think we would need params
I
on
see
that.
where you're getting.
Yeah.
I see where you're getting into. You can combine multiple actions into a single one, and that will be effectively the same. I agree.
Yeah, the if
So-
would be way better than the action of fall. So
So just make sure I understand. This is past a mutable JSON type info that it tweaks however it needs to tweak, and then upon that delegate returning, the system composes a new resolver based on it. Is that
Correct.
But what does that composition look like though? Because you're modifying the input.
No, that's actually the output of the resolver.
I guess what I'm confused by is how does the input resolver argument relate to the return value of the method?
I would say that we shouldn't be mutating the input by appending the modifier to the source, unless we do a fluent style API. I think it should be returning a new instance, and the input resolver should not change in how it acts.
Right. So
sorry,
the,
I'm go ahead, Leo.
I was going to say, so the method is called modify, which to me says this method has a side effect and doesn't return anything. Yet
enough.
the method has a return value. So I'm very confused as to how these two things meet.
Maybe it makes more sense to introduce a class, something like what Jeremy just wrote, rather than having the modifier, because that will be imply that you can modify it and you act on the single instance rather than.
I misunderstood. So modify resolve type info doesn't invoke the modifier. It stores that for later use by whatever resolver it creates.
yeah.
I see.
Well, again, I'm just looking back here at, this is variant 3, but not as extension methods. So this is with callback of how do we make it be not an extension method. It's, you want this resolver to do some work, but before the serializer actually gets to touch it, you want to run it through this modifying function. My name is entirely me writing things down because nobody else said anything. So 100%
So
open
those-
to
No,
mutation.
your snippet helped me to understand what it was actually doing.
Yeah.
Yeah.
Yeah, the question is, I guess, do we need that static method? And if we don't, then do we need the class which modifies? So basically modifying resolver, because I feel like modify resolver, I guess I feel like it will be easily misused and people will call it multiple times. That's my gut feeling.
I mean, again, so especially if we think that we have a hard time coming up with a name for the static here, then this could just be, public class JSON type modifying resolver.
I mean, I should point out that the motivation for incorporating these combinators was to avoid having to implement your own IJSON type info resolver.
Yeah, so you wouldn't have to implement it. You just have to say new.
Okay.
Right, and then now it looks like that. And
you can, of course, then there's always the distinction or the option of, instead of introducing a new type with a constructor, you have a factory somewhere, create modifying resolver that takes it and returns the IJSON resolver or whatever.
yeah, and again,
Yeah,
maybe
which
that would
would
have been,
be here.
instead of modify resolve type info, this should have been create modifying resolver. Right.
Right.
Yeah, I didn't
Which
want
wouldn't
to
have
give the impression.
have taken a resolver argument.
Well, it would need to know the resolver that's going to do the base resolution.
Wrap.
No, you
Yeah.
would wouldn't you just use it with combine?
I assume it would wrap an existing resolver that you pass as an argument. So you could potentially call combine and then take the output of that and feed it
Yeah,
through the
so
wrap
you'd have-
method.
Ops.resolver is JSON type info resolver dot create modifying resolver. Freaky that it read that through a comment of JSON type info resolver dot
Modifier.
like that. Yeah, I have the right number of parentheses.
Yeah, that is very not readable.
It's JSON serialization,
Alright.
so it's par for the course.
Well, what's not readable about it?
Well, it's more like the order of operations is not necessarily how your brain functions, right? So I mean, at that
So
point, the
split it
question
into
is
two lines of code.
well, or
what's
just
the-
literally derive from the type and write the code out, right?
What does combine actually do? I think where I'm struggling is what does the combine operation actually do? Like when does it choose to consult the next resolver in the sequence? So I call the first resolver and it gives me something back. At that point, does it stop consulting subsequent resolvers? Or does it go to subsequent resolvers and ask them for the same thing to see if they want to override? Or how does that work?
It returns the first non-null result. So the interface type can actually return a nullable JSON type info. So, you know, if the first one is null, it's falling back to the second one.
So the modifying resolver, subject, except for the name, which suggests that it is modifying something else, it could, if it doesn't want to give anything back, we could come up with some way to just basically say, let me rephrase my question. If a resolver doesn't want to give something back for a given type, and it wants you to instead go to the next thing in the line, what does it do? Does it return some sentinel that says, I have nothing for you?
Yeah, it's called null.
Okay, so why wouldn't you could imagine creating the modifying resolver that just returns null if it doesn't know how to give something back, right?
Yeah, again, my understanding, and I would love for somebody to back me up on this, is the modifying resolver is when you want to write something that does all of the default work except, for example, puts an underscore in front of the JSON serialized property name. Do all of the work you would have done to build this data to the serializer, but I want to tweak one aspect of it.
So it behaves. It relies on some other resolver. It gets the data from that other resolver, and then it modifies it before constructing a new resolver based on that modification.
Well, this modifies the returned type info object, so it's the last ditch. Go tweak this before we actually use it for serialization.
I see. Okay, I got it.
And there would be no need for the delegate to actually return a value, because if the delegate wants to no op, then it just no ops return.
Yeah, and the delegate, and as written using the base proposal, so what I have here based on what came in, has no ability to now intercept it and return null. Because it's action. The object has been created.
Yeah, that's the thing that was confusing me earlier, and I think seeing this, I understand it better now.
So a modification would never be, yeah, that resolver gave you something back, but I want to pretend that it didn't. That would require you writing your own resolver. This is, yeah, that one gave you something, and I just want to change its name.
Yeah.
Yeah, and I think, like, to Emo's point about the call sites not looking very user friendly, I wonder if that was simply an artifact of the fact that we had a fairly lengthy line that was combining both combination and modification. Like, if we have two lines, one that says line A combine, line B modify,
Right.
then wouldn't that be more appropriate or more readable?
I mean, if you wanted the underscorification resolver, then this would just say like default JSON resolver. So, but yeah.
I mean, I feel this would be much shorter if we just used extension methods, though. Going back to the original discussion.
Fluent syntax, right?
Yeah.
This
Well, there could be instance methods, right? If we just object to them being extension methods, you could just make them instance methods. The only problem with both approaches is that when you combine multiple things, that's the same problem that enumerable.zip has. It's not necessarily intuitive, right? Because you say A and then, concat B comma C, right? Which reads very weird. But if the canonical phase, you just combine two things, then, static or extension methods make sense because it's fundamentally like an inline operator, right? It's like, A times B kind of thing.
I mean, if we want to put a stake in the ground and say like the BCL, which system text JSON is kind of a part of, has this opinion that we want fluent syntax, then we can make that claim and go for it. I think we've been very hesitant to do that though, for the reasons that Emo just stated.
We have it in some places. It's just
we have it on string builder. We have it on link.
It's not. It's definitely not our go-to pattern.
Yeah.
Yeah, I agree. Like, I think there is cases where it's kind of natural. I think link is one of those examples where it feels fairly natural to do that. And I think string builder is an example where it just does not. It's just we have done it this way, but I don't think we would do it if we were to start from scratch.
Yeah.
Right.
This one, I'm undecided. I mean, I'm not saying that Fluent would be better. I'm just saying that what I have on screen right now is not necessarily intuitive, but I don't know how to solve that. I guess my uber point is that, are these helper methods helping you that much? Or are you better off just writing your own type that extends JSON type info resolver, takes the right arguments, and then you do whatever the heck you want? And the answer might be no, right? I'm just saying that.
Yeah. Well, because I think from the serialization perspective, right, you've got these contexts, then basically you're going to end up with, ops.resolver is JSON type info resolver dot combine or cascade or concat or whatever we want to call it, with, foo context dot default bar context, and then the default resolver dot instance or whatever. And like that's the only line of code that most people would write.
I kind of disagree. The usage suggests most of the people will use modifier, and they will only use a single modifier with the default JSON typing for resolver. That's maybe why we should answer it.
So there's nothing against us adding like accelerator methods to things like default JSON type info resolver that's like dot apply modifier, and it just takes the action and that's it.
Right.
Like it modifies the instance that you call it on.
The question on that becomes again if is it a property of modifier, and so there's only one delegate, or is it a list of delegates? In which case, does the order matter and all of that stuff?
Yes, order matters. I would call it I list of action and make it call it modifiers or something like that.
Yeah, and certainly we can do two things. We can make there be the combining or cascading or whatever static for when you want to glue things together, and we say that the modification basically only occurs on the default one, and so we don't make a type for that. We just make it be the list.
I mean, this could be implemented as an accelerator that literally looks over the I list that's exposed publicly, like combines them all, and then applies a modifier to them, and then shoves that one remaining entry back into the I list. Like, that would work. That would be an appropriate implementation, would it not?
Well, if the I list is only on the default resolver and not on the serial or the source generated objects, then like you don't have a thing to modify. You don't necessarily have a thing to modify. You can't rewrite the property because it's not a property.
The accelerator I just mentioned was also on default JSON type info resolver, because I think Christoph just said that is the common use case, right?
Yep.
So you can still get the fluent syntax if you want to. It would just be a regular old instance method on the type that we expect is going to be the 99% use case type.
I mean, I'm still struggling with what Christoph said earlier. He said the most common case is modification, not combination. That seems odd to me, because I would expect most people just want to say, oh, I have one resolver that is for my type. I have a different resolver that is for other types. I just want to use both of them.
No, the most common case seems to be something along the lines, I want to remove all of the properties which are called password, or I want to change some like empty lists so that they don't show up on the JSON, something like that. Those are the most common scenarios I found. There was actually very little scenarios I found where people build it from scratch. Like
yeah, I should point out that Newtonsoft uses reflection-based serialization only. So the idea that you have one resolver that kind of generates metadata for everything is kind of a given. But in system.text.json, we have sourcegen, and in sourcegen, you actually have this concept where you have different resolvers that generate metadata for different subsets of types. So this cascading combinator specifically makes sense in the context of sourcegen, but it probably doesn't make any sense in a reflection-based serializer like Newtonsoft.json.
Well, for sourcegen, oh, sorry, go ahead.
I mean, another way you can solve this is by just saying what we have on screen right now. Basically, you have two properties where you can just chain stuff, and there's another property where you can modify stuff. And then we would just say, well, first we walk the chain to find a resolver that is not null. Once we found one, well, then we pass it through the modifiers. If anybody that wants to modify them, they do, and then that's the end of that. And then if you really say like, okay, that's not flexible enough, well, then you derive from type resolver and do whatever the heck you want at that point, right? But I like that because that is easy to read. Like you say resolver.chain.add or resolver.modifier.add, and then that is brain that simple at that point.
It is, and it also solves the problem of you don't have to worry about what order you call them in. Like if we have a fluent syntax where you call combine, then wrap, then combine, then wrap, and interleave them, like the order in which those lines occur might dictate, how those operations take place. Whereas if you're looking at these two properties, it's very clear that the resolvers run first as a unit of work, and then all the modifiers run as a unit of work. And it doesn't matter in what order you added them.
And that probably solves it for 90% of people, right? And the people that do need to do this crazy thing first, well, then they have to extend the type resolver.
It might be worth pointing out that this particular design kind of forces default JSON type info resolver as your entry point for making these types of combinations. But the issue is that the default resolver is the reflection-based resolver, and as such, it is marked as requires unreferenced code, and it cannot be safely used in conjunction with the linker or AOT. So, as mentioned,
you lost me at the first part. Like, why does this follow from this design?
So by exposing combination patterns as properties in the default JSON type info resolver, you're effectively attaching them to a class that is marked as requires unreferenced code.
Oh, I see what you're saying.
Yes.
So you're not opposed to these two properties. You're just opposed to tying them to the default one.
So I would say that.
I mean, the easy answer on that is. Also,
well, I mean, I would have just said wherever the resolve property lives right now, which I think is the JSON serializer options, I would just say, instead of having resolver, you would have resolver chain, resolver modifiers instead of resolver.
What if I wanted to apply a modifier on the first component of the chain and not the second one? Or if I wanted to apply separate modifiers in each component of the chain? Like, you can compose these things any way possible, and,
I think that's more of a pit of failure, though, because from everything that we were hearing over the past few minutes, it sounds like people reasonably expect the resolvers to go first, and then the modifiers to be applicable to every resolver, regardless of which one actually hit it. Like what you're saying is a good power user scenario where I want to apply a modifier to a very specific resolver. But if we have, as Jeremy has on screen here, like JSON type info modifying resolver, sure, you can do it. Just wrap the resolver yourself and then shove it back in the list.
Yeah,
and now
absolutely.
that modifier is a resolver.
So my recommendation would be that we might want to add a modifiers property in the default resolver, because that's where 99% of the modifier pattern would apply anyways. But I don't think there's a lot of value in introducing the resolver chain. That could be the static method, the static combine method, because typically when you combine things, you want to combine different JSON serializer contexts. And again, this is a pattern that we theorize might be useful to users. We haven't actually seen, actual requests saying, oh, I have two different instances of generated metadata and I want to combine them within one serialization context.
Well, correct me if I'm wrong, but I understood your earlier comment about source generation as being that kind of the thing, though, no?
It is, but I would say that this is kind of a different world to the default JSON type info resolver. So as such, we might want to keep these accelerators separate.
Sure. I mean,
I understand that. I understand that the default one, because it's tied to reflection, is special. I guess my mental model would be, if what you said is true, I only want to modify certain types. Well, your callback in the modifier can check that and basically just say if, adorn type equals customer, do something, otherwise do nothing, right?
Yeah, I mean, really, I guess the question is, do you think it will be common that someone will want to modify a thing that came out of the source generator? Because if it would be a,
it kind of feels like,
if it's going to be a common thing, then that means that the modifying the give me an action is a universal thing. But if it's really only the reflection-y one, like it does things, and maybe I want to intercept and apply some other sort of transforms on top of it.
Yeah, I would say that modifying metadata from sourcegen kind of defeats the purpose of sourcegen, which is to kind of minimize startup times, because you specifically don't need to do this type of metadata manipulation. But on the other hand, combining resolvers feels like it's a real scenario. Like one example I had in mind is, suppose you're consuming a NuGet package that is exposing a JSON serializer context for a bunch of types that it uses, and you want to combine that with POCOs of your own. In that case, it feels plausible that you might want to combine the two, but at the same time not needing to rely on any of the reflection-based resolution.
Right, so that would just be my types, its types, and we're done.
Yep.
And yeah, so I mean, like, you guys are the ones who know the use cases. If you think that modification really only applies on the default, then I can buy.
Certainly, we know for sure that will be most common for the serialization context to, like, we don't have enough data yet because this doesn't exist yet, but I guess we don't expect people to yet.
So I can buy. We add the list of modifiers only on the default resolver type. We add combine, cascade, collate, whatever you want to call it, on as a static, just to make it easy to do the combining a bunch of contexts. And if you think that that's 99% of all your use cases, then that sounds reasonable to me.
Yeah, I'm happy with that. I mean, for the record, I would say that I'd be happy with us not shipping any of these, but this exercise is valuable because it helps us understand whether the underlying core abstraction is sound.
So, of the uncommented API on screen, does that sound like it solves the problems to people?
Yes.
Yep.
Tanner, Levi, Steve?
Steve had to go.
Fair enough.
But I think this is fine. Yeah.
And the rest can be added later. Like if we find people complaining, okay, this is like why don't you have the list of the
Right. Like combine is the one that I understand the most, and that's the source. Like this new feature plus source generators equals you need an easy way to link a bunch of these things together. So the combine is the only part that I know enough to care about. Um, the rest was me typing things because they were being discussed.
Yep, I think this is
Yep.
is enough.
Okay, so is this all right? So now that we have modifiers, are we leaving the default type sealed?
For flexibility, I'd still kind of I'd want to enable the dev that relies on copying and pasting Stack Overflow code and changing type names.
Fair enough.
And I assume the get type info becomes virtual at that point, because otherwise it's useless to make it unsealed, I guess.
Yep.
Okay.
I think the original did have it virtual.
Yep.
I just wrote down that we had the discussion.
Type a command, like I will modify this.
Well, because from the oh no, this is the top one. So the top one has it virtual. So I just don't know what to paste in now. And are we done? Is this it?
Yes.
Yep.
Okay. Yes, that was the only two questions we had.
All right. So which is more up to date, the bottom one or the top one?
The top one, I believe.
Because I don't remember if there's anything else that we renamed.
No, we we adjusted the stuff in the top one for the stuff we were sure they're correct, and the complete object we didn't add because we didn't think it's good to add it now, and the same stuff happened for the combination patterns are missing in either, so we basically need to copy paste whatever, add those APIs and modify the.
Okay. Yeah. It looks like the top one got rid
I
of
don't seal
the withdrawn generic. Where's the? No, it was removed.
Just
So.
you can say something like original proposal with following modifications.
Well, but emo always has us put the whole API surface that's approved in, so it comes out in the email of the meeting minutes.
Fair enough. Makes sense.
Okay.
I'm nice like that.
That's how you summarize a 2-hour discussion. Now I need to take the things from my notes. So that's. All right, so combine is the name we want to go with.
Makes sense to me.
Combine sounds good.
Cascade sounds overly complicated.
Okay, and then we need the static helper type for putting the combine out, so I'll plop it right about there. Okay. So I think that got everything.
Never mind. Sorry.
Okay.
I thought I saw something that wasn't there. So fine.
Okay. I copied the proposal from the top. So hopefully that was up to date. Oh, we probably shouldn't call it REST. We should probably call it resolvers. Okay. Going once. Twice. I see no comments from YouTube. Sold. Alrighty.
Awesome.
That was three issues I think we got through today. So, but that's still 3 more than 0. Okay. Das ist alles die Zeit that I have, and I don't even remember if Zeit's feminine. So, right. So we are out of time, and I'm hungry. So with that, I think see everyone on Tuesday.
Yep, danke schön.
Bitteschön.
Bitteschön.
Thanks everyone.
Alright.